Now, one by one, let's start off with electrification, which basically is that parts of the powertrain, at least, are being replaced with electric components. That means battery and electric motors replace the tank and the engine. And the hope really goes that this helps a lot with the emission problem, with the consumption problem. It's unclear if it actually can help with the congestion problem, because I noticed that since we got so many great electric vehicles to this area, that the carpool lane has gotten much, much slower. So you can ask the question, how much of a help is that really? But still, the hope goes that electrified vehicles are actually cleaner than others. And at this point, we could also talk about other alternative fuel vehicles. We could talk about natural gas vehicles. We could talk about liquefied gas vehicles, maybe hydrogen-powered vehicles, and so on. But I really want to direct the attention to electrified vehicles because it's really on the agenda of many countries. I put our own home country here, the United States, on this chart. I put China on there and my home country, Germany, on there. So we all have these targets where we say this is the percentage of electrified vehicles that we want to have by a certain date. And then the discussion actually starts, what actually is an electrified vehicle? Is it allowed to have maybe a little gasoline tank, or has it to be battery electric only? And that's exactly what I want to discuss a little bit more maybe in the next 10 minutes with you when I actually ask the question, well, how much electrification do we actually want? How much electrification is right? Which is also one of the research topics that I personally tackle at Stanford. Really, how much electrification is right? Right for the planet, but also right for the consumer, that we can have our independence, freedom, and flexibility that we all enjoy so much with our vehicles. Now, but the questions really that we need to ask regarding vehicle electrification are as follows. Can an electric vehicle really help with slowing down global warming? And that obviously is a big question. Where does the electricity come from? When you basically just get the electricity from a coal-powered or from a coal-fired power plant, then maybe you just displace the emissions from the exhaust to the smokestack, and not that much is one. But it might be, again, different if we're looking at, does it help us with the dependence from scarce or maybe foreign resources? And therefore, obviously, next month there will be a talk about hydrofracking, which obviously shifts this equation already. 5 years ago it was all about dependence from foreign oil, and now it's like, well, South Dakota is the solution, North Dakota. And there we see already how quickly this can shift, where it's also then really tough for car companies to follow those trends if it's all of a sudden like, what do you mean shortage in oil? Peak oil? Does it really happen? I personally think it does, to be clear. And I also believe in the effects that we all have on global warming. But obviously, it's still a very much heated discussion that's going on. Decrease air pollution is not the same thing as the first 2 points, because that really is what happens maybe in the cities, and where it might help a lot if you have electrified vehicles in the city, even if you generate maybe electricity outside the urban areas, where we saw those numbers, 40 to 60 billion in damages to health. That obviously happens because the pollution happens in the cities. How well does it integrate with electric infrastructure? I don't have too much material on this with me tonight. But there's the question, well, can the electric grid actually sustain all these electric vehicles? The answer seems to be yes. Maybe a cul-de-sac here or there might have a problem with a transformer. We have this neighbor effect. My neighbor's an electric car, therefore I need to an electric car, therefore my neighbor needs to get an electric car. That might put some challenges on the very local grid. But in general, since we are not expecting like a revolution all of a sudden, really get all these electric vehicles on the grid, that hopefully the grid will adapt to the demand that we get from the electric vehicles. But the last one might be the most important question. Since automobiles in the end are free market. Yes, they are highly regulated for safety and emission standards, some others as well. But after all, the consumer makes a choice. And I really had a lot of discussions like a Prius. You know what, I will get a hybrid vehicle, but I just don't like what it looks like. And I said, well, what do you mean? You're just sitting in it, but if you really want to make a difference, you might want to get it. Well, yeah, I might as well. But now Tesla obviously changed this a lot, where people say, that's a vehicle I aspire to. So there we see already, it's not just so much about what is the car, does it get me from A to B, and what is its miles per gallon or its kilowatt hours per mile or something like that. It's much more, it's a whole lifestyle. It's, do I want to be seen in this vehicle? Do I enjoy myself in the vehicle? And therefore, I think there's not just one answer how we tackle the challenges regarding electrification. One slide that maybe some of you know, what's on here is on the horizontal is really how much or how many miles the vehicles travel every day. It goes all the way to 180 miles. Not many vehicles travel much more than 100 miles actually, average a day. And on the vertical, you basically see the cumulative daily distance. So basically, to the top, you get 100% of all vehicles. And if you look at these two red lines here, then you see in this line, can you see my pointer? Yes, you can see my pointer. That about 50% of all vehicles, and the numbers don't really differ much between Germany and the United States, for instance. About 50% of all vehicles don't drive even 20 miles on a given day. And 80% of all vehicles don't drive more than 40 miles average. And this is where then many of these statements come from. Everyone should be happy with a 100-mile range electric vehicle, which would be roughly here. We say, well, maybe not everyone, but 92%. Fine. But that is really the question, because are we really happy then if we say, well, that's like the average use case? Because we don't purchase our vehicles based on an average use case. We basically purchase our vehicle based on this. We're thinking about, well, for how long might I own this vehicle? Maybe 4 years. What might happen in the 4 years? Maybe I want to see my aunt in Eugene. Maybe I want to go to Tahoe. Maybe I might want to move somewhere else. My commute gets longer. I don't know. So I want to have all these options. I don't want to be locked in with a vehicle where all of a sudden I figure out it doesn't do it for me. And that is really the thing, that the automobile is not just a mode of transportation. It's not just a transportation device. It's really independence, freedom, and flexibility. And when I say freedom, it's not just a very masculine thing, like getting in a car, hair blows back, and I can really be myself. It's also that you can go to a yoga class whenever you want. It's also if your book club meets every Wednesday night somewhere out here in the valley, you can just go there. And if the book club is not over at 9:30, but maybe runs a little bit longer, but someone has to talk so much, runs until 9:45, then you're like, I'm not quite sure where I find a bus around here, and I don't really want to hang out in this neighborhood, and then not sure what happens. It's just this freedom that you go to a book club, and after the book club, you can get in this car, and you get home. So don't forget this. The automobile is so much more than just getting from A to B. It really enables us to get places. Now, we did a little study at Stanford when we basically made up 10, well, we didn't really make them up. We interviewed 10 personas and then categorized them. What would happen if this persona would get a standard Toyota Prius, a plug-in Prius, a Chevy Volt, a Nissan Leaf, or a Tesla Model S? And then what is the roughly annual miles per gallon equivalent? And how many trips would they need to skip? Persona 1 just happens to talk to you right now. That's me. So I could not do 8 trips per year if I bought a Nissan Leaf. I could not do 3 trips per year if I got a Tesla Model S. That's basically, if I want to have a great time, my wife and I would get maybe on the road, go to Santa Barbara, and back on the same day, getting a little bit tight with the Tesla Model S. Yes, I know there's supercharger and everything, but still, does all this work out? And that is really the thing. Is this trip important to me? Could just skip it. Just a fun trip on the weekend. But after all, this might be why I'm purchasing the car in the first place. And this is really my point. If a consumer doesn't consider this efficient vehicle because you cannot do some of the very few trips, but they might be very important to you, then we lose really great opportunity to have a more sustainable model, to have a more sustainable vehicle altogether. Now, we could do something. We could maybe put in better batteries. I have a slide here. I want to speed up a little bit because we have a few more topics to cover. But if you look at different batteries, we basically have the density of energy and over mass and volume in this depiction. I'm happy to discuss more details later on. Where we basically see batteries, even in the best case, this is lithium ion, and here's even lithium air batteries, are still a magnitude off from what we have from diesel or gasoline today, which really means we need a behavioral change where we just need to understand it just is not the same range that we're getting out of the same system. Or if we wanted to look at charging models, here different levels of charging. I assume that some of you are familiar with level 1, level 2, level 3 charging. Roughly speaking, level 1 charging is what you would get out of every wall outlet here in this room. Level 2 is a little bit more basically where you might hook up your electric washer dryer at home. And level 3 is fast charging. And I even put in the Tesla supercharger down here, where roughly if you could use this for Nissan Leaf battery, best case scenario, really in 15 minutes you could charge up this vehicle, but more realistic, it's charging overnight. And the same amount of energy we would get in 1 minute out of the nozzle at a gas station, because a nozzle at the gas station gets you actually 10 megawatts of energy or of power to the vehicle. So maybe there are other solutions for range. Yeah, we could put an even larger battery. This is what Tesla does. Really great company. I love the product. I have a lot of admiration for what they are doing. I visited them 2 weeks ago, saw the plant in Fremont. If you ever have the chance to see it, it's really impressive. They're doing great things. But maybe there are other ways, actually, how we can come by the range problem. And there could be a range extender. I'm pretty bullish on the range extender, because that is exactly the use case that we saw in this curve earlier. If we don't drive that much in every day, if we only drive 20, 30, maybe 40 miles a day, if that is on electric-only fashion, and then we have a relatively lightweight generator and combustion engine in there, yes, that is roughly the Chevy Volt model, then maybe we can come up with a relatively lightweight vehicle, as opposed to moving around a relatively heavy, in the order of 800-pound battery every day. When we are moving around something every day that we don't use every day, which might be somewhat similar to having an SUV or a pickup truck. I might use it once or twice a year, and therefore I move around this extra weight every year. And that might be somewhat similar to moving around a very heavy battery. And there are some great research results from Carnegie Mellon. I didn't include them in this slide, but I'm happy to point you to references. Well, Carnegie Mellon did a great life cycle assessment, so overall what happens through the life of a car, and where actually the range extender looks pretty good compared to those vehicles that put in a pretty heavy battery. But maybe there's even more. Maybe Stanford can do better, and we are working on something which is called dynamic charging. So as the vehicle moves along on the highway, if you have quite some infrastructure, that you can transmit power to the vehicle. That is not an inductive charging that you might know maybe from some other application. It's magnetoresonance. So it's a magnetic field that basically only if it's the same resonance frequency that the coils in the vehicle have. So it doesn't really cause harm to people or animal or other electronics in the vehicle. Then you can actually come up with a pretty nice, very efficient concept, a lightweight electric vehicle that gets electric power as it's moving along on the highway. Now, certainly that's not cheap. We need to put on this infrastructure. We need to put in segments every so many miles, probably more like hundreds of feet on the highway to actually get these transmitting elements in there. It is estimated that per highway lane mile, so if you have 2 miles, you have to 2 lanes, you need to multiply this roughly by 2. But per highway lane mile, it costs about $1.5, $1.6 million or something like that. Not free, but not sure if you're ever having a talk here on high-speed train in the valley. Also not free. So you really need to balance this off what you want to do. I'm a believer in train, believe me, coming from Europe, but also driving a car might be an interesting thing. So with this, I want to move forward a little bit and summarize this field so that we get to the automation. So if we summarize the electrification, there's really 2 things, 2 main trends that I see. One is really on the vehicle side, but the other one is really on the user side. So that we need to see what technology improvements will help us to actually get to a more sustainable, to a more efficient propulsion of the vehicle. And there's some work happening on battery and charging systems, but I really want to consider the range extender as a pretty interesting option that I would not just see as a transition. It might be actually a long-term solution to stay with us. And we see actually more and more vehicle manufacturers coming with their range extended battery electric vehicles. But also really behavioral change. Do we need to ask ourselves, how much automobile do we actually need? And even more maybe, how responsibly am I using it? Should I maybe seek other modes of transportation? And especially if I have smartphone apps where I really see, well, you could take your car, could get there, but you know what, you're just stuck in traffic and so on. Just get maybe to the next public transportation station and guaranteed you will be there faster and so on. And also then connecting this with charging options. So I think information, if we use it wisely, can actually help a lot also that we just get by with lightweight, more efficient electric vehicles. So much about electrification, and I'm happy to take more questions later on, but first we talk about all the other topics.